Welcome to the Smart Mobility Summit, and welcome to Las Vegas. So we're going to have an interesting session today. We're going to have two discussions. So we're going to start now with the first session. The first session is about transportation evolution towards the more sustainable and efficient future. So my name is Barbara Parello. I'm the Smart Mobility Lead, so I will be the moderator for those two sessions. So, as I said, this is the title of the session, and we have a very intense agenda. So, we're going to have first a keynote presentation from Cameron Corsi, which is the Vice President of AT&T Connected Solutions. Afterwards, we go to the panel, and we will go through an interesting discussion with our panelists on topics related to connected vehicles. So I don't want to waste too much time, so I want to actually welcome on the stage Cameron Corsi. So please give a welcome, an applause. Thank you. Thank you, Cameron, for being here.
All right. Smart mobility. That means a lot, right? We tried to name things smart everything at one time, and we got to smart assets, and we thought, that raises too many questions on what you're really saying. So we started calling it connected instead of smart. So I'm in the Connected Solutions organization in AT&T. To us, that really means Internet of Things. And a large part of that is what we call next generation transportation. And so what I'm going to talk to you today about is really the rise of connected infrastructure. You might have heard the term, probably have, intelligent transportation system in the past. We call it connected infrastructure because we think that invokes more use cases than just intelligent transportation. And it gets to the point that you need connectivity in order to make this a reality. And as we move into the 5G world, we think that we can do it better than ever as an industry to provide connected infrastructure, not only in the United States, but around the world. So, before we talk about the future and where things are headed, let's talk about where things have been in this space. In the 1990s, we were talking about vehicle-to-vehicle communication with a technology called dedicated short-range communication, or DSRC. This is, as its name implies, short range, and it was meant to provide basic safety messages between vehicles that would help to avoid collisions. It was a bumpy road to deploy DSRC for a number of reasons, one of which is you have to have a lot of vehicles on the road having this technology in order for it to be able to really make a difference. So a lot of work started to happen after that, and the realization occurred that, you know what, this isn't just vehicle to vehicle that we need to solve for, it's vehicle to infrastructure. And when you think about infrastructure, think about traffic lights, being able for your vehicle to be connected to a traffic light. Think about in terms of vehicle to pedestrian, being able to help a pedestrian who might have a smartphone, maybe a cyclist, to be able to avoid having a collision on the road if they're on the side of the road with a vehicle. It's actually about vehicle to anything, really, when you come down to it. And so there was spectrum that was set aside for this vehicle-to-vehicle communication. Around this time, though, the industry started looking at alternatives to DSRC, something that would work better with cellular chipsets and would be able to be deployed in a much broader scale than what DSRC was. So the industry got together and formed what's called Cellular V2X, based upon 4G LTE technology and rolling into 5G in the future. This was specified, and a large contingent of the industry, automotive, cellular operators, and all the various components that go into this to make it work, have rallied behind this idea of vehicle to anything using this new technology. However, at least in the United States, one of the things that happened is the FCC took part of the spectrum that was devoted to this vehicle to vehicle, and they decided to use it for something else. This wasn't not in the cellular band, it's another band. But because of that, the things that you can do, the things that the industry had planned on doing with cellular V2X, you can't do everything that you would like to in this frequency band that's allocated for it. So now that comes to vehicle to network. There are some messages, there are some signaling that can happen here across the cellular network, since it all can't happen on this unlicensed band. This is vehicle to network. And another reason why vehicle to network is so important is if you're just talking about short range, 300 meters kind of range, you cannot send all the information to as far back as you would like and as far back as it would be valuable. Think in terms, and in 2017, we actually, at a CES show, did a demonstration of this, of vehicles that can send information in through the cellular network to a centralized server that can analyze the data, that can identify, let's say based upon tire slippage, that the road conditions are bad in this area, so it can alert vehicles much farther away of danger ahead so that they can reroute. You can't necessarily do that with short range. You can do that with a combination of short range and the vehicle to network. So we are in the era of cellular V2X, and a large part of what we can do is vehicle to network going forward. If we look at then what happens next and where we think we're headed, we think we're at a pivotal inflection point. We think we're at a place where this might actually take off this time. There were many failed attempts at DSRC. There is equipment rusting along the side of roadways today because we couldn't get the economies of scale for the entire industry. However, between public and private use cases that are coming together, we think that it is the right time for this to really take off. Let's talk about the public ones for a minute. Think about safety and where things are headed from a safety perspective. As autonomous vehicles come out there needs to be a lot of safety that comes with them, right? People are nervous about that. So we need to make sure that in the public interest is taken care of. There's a lot of work going on public transit around not only the United States, but around the world. And that requires this kind of connectivity as well. You know, we're also moving into an era in the United States where we have the FirstNet network and we have first responders that basically have a piece of the network that is guaranteed that they can use going forward in an emergency. Well, part of the networks going forward could be used in this case in the automotive and transportation domain for something similar. So that's on the public side. But on the private side, you've all heard about what's happening here, about electric vehicles, the proliferation of them. When you have electric vehicles, you need to find EV chargers. You know, you need to know those EV chargers are working. You need to know where they're located. You certainly don't want to arrive to one and find out that they're all consumed and you're going to have to wait, hours before you get access to one. So you want them to be connected. So there's a lot of connectivity that's necessary in the EV space. For autonomous vehicles, we talked about as well, why that's important. Another buzzword out there is software-defined vehicles. It's really more than a buzzword. It is where vehicles are headed. More and more things in vehicles are being controlled through software. There are various examples that you can find out there of feature functionality that is being enabled over the air after a vehicle has been sold and you upsell to a user another capability, right? So software-defined vehicles also means that you need to update that software over time. You want to make it better. You want to fix things. You want to avoid recalls by doing software updates over the air. Again, requires a level of connectivity above and beyond what we've done in the past. So this inflection point is really the coming together of public and private interests. And there's a great deal of money that the governments have made available in order to realize some of the vision that I've mentioned here. That's one of the reasons why we think it's the right time for us as an industry to go the extra mile and to make this real for everybody. Let's talk about the compelling use cases for a few minutes. One is vulnerable road users. I already mentioned pedestrians. If your cell phone has the capability to alert you, or for that cell phone to alert an oncoming vehicle, then you can avoid dangerous situations with pedestrians. Traffic optimization is getting more and more important. Look, it costs a heck of a lot of money to build another lane of road, doesn't it? So any way that you or we as an industry can figure out how to be smarter about traffic optimization, how to route traffic in a way that is more efficient, it's going to be helpful in a variety of use cases. I already mentioned charging station, and I gave you that example. And then shared mobility as well. We're moving into a time when there are robo-taxis, when there are transit buses, and in the future, some of these will be autonomous. These need connectivity to make sure that they're updated of obstacles or changes in the roadways, things like that. So all of these are compelling use cases. I would submit there's a lot more than even this that we could be looking at solving together. You know, here's one more example for you. And you can see it demonstrated over here on this Ram truck. Haas Alerts provides the capability to display to the driver on their head unit of an upcoming emergency vehicle that's in their path. This can help to make sure you as a driver avoid that emergency vehicle, and so that it can get to where it needs to go as fast as possible. This is not pie in the sky. This is happening today, and you can see it demonstrated right over there, right there. So key to all of this is the common thing that brings it all together is connectivity. Not just the ability to see things within your line of sight, but the ability to see things beyond your line of sight. That's where cellular comes in. Again, 300 meters, short range. We can go miles and miles. We can go across the United States with cellular. We could talk about teleoperations, where somebody on one coast is basically driving a truck that's on the other coast. This all can be accomplished with some of the new technologies that we're bringing to bear in 5G in particular. Okay, so I hope that this stimulated some thoughts in your mind about where we can go with connected infrastructure, with smart mobility.
We are going now to just give an introduction. So obviously I did introduce you one by one. So I just will go through each of you, just maybe if you tell who you are, who you work for, and if you can tell a little bit what are the area of interest on smart mobility. Can I start maybe from Steve, from your side?
Sure. My name's Steve Schwinke. I'm the Vice President of Customer Engagement at Sibros. I've been in the connected vehicle space for a very long time, and putting, OnStar on vehicles when people didn't realize the value that having embedded connectivity made sense. So I was with GM OnStar for 22 years. I'm now with Sibros, been there about 3 years now. Sibros is a company based in San Jose, California. We provide a deep connected platform, and we enable our customers to do full vehicle data logging, remote over-the-air software updates at scale, and send remote commands to the vehicle, really helping our customers build a better product and bringing that vehicle into their customers' digital lifestyle. So thanks for having us.
Thank you, Steve. Kenta, can you introduce yourself?
Yes, sure. Hi, my name is Kenta Yasukawa. I'm CTO and co-founder of Soracom. We provide a smart connectivity platform for connecting vehicles and any things in the world. So in a sense, we are global MVNO providing connectivity over cellular network. One of the important partners is, of course, AT&T, and we have worked with NTT Docomo and various carriers all over the world so that we can securely connect the vehicles or smart mobility devices to the cloud. We consider ourselves as a kind of a glue between all the important technologies for achieving connected infrastructure. We built our cellular core network on top of AWS cloud and provide connectivity through partners like AT&T. So the vehicles connected through AT&T, next hop is already AWS cloud, and they then connect to IBM or Sibros or other cloud solutions. So that's where we operate in this connected infrastructure. I'm so excited to be part of this panelist. Thanks.
Thank you, Kenta. And Chris?
Yes, good morning, everyone. I'm Chris McKenna. I lead business development for private wireless for AWS. Private wireless, enterprise mobility, private cellular, lots of names for the same thing. I'm in our telecoms business unit, so I'm primarily focused on how we help telcos to build enterprise mobility solutions on AWS. So focused on telcos, but also on global systems integrators across many different industries, actually. But I think automotive is one that we really see as truly leveraging the data that comes off vehicles, the data that's available in supply chains, the data that's available in manufacturing processes. So a very wide breadth of solutions across automotive. Really, we're seeing this move towards the software-defined vehicle, and what that really means is interesting to us because the parallels with cloud computing, which is what we do, is really clear. The abstraction of data away from the underlying hardware and the software that sits on top of that and the features that can be enabled really drives the industry forward, and that's what we're so excited to see. Thanks.
Thank you, Chris. And Bill?
Yes, well, good morning, everybody. My name is Bill Lambertson. I'm the Vice President for our Cloud, 5G, and Edge business, focused on the telecommunications industry and then the ecosystem enabled by the telecommunications industry. On behalf of IBM, I'm honored to be here. And when we think about what we do in this space, IBM, at its core, is a hybrid cloud and data and AI company. So we focus essentially on probably four main areas of the connected car ecosystem or value chain. The first is with our solutions from Red Hat. We provide the ability to do some things on the in-car operating system. So we've announced some capabilities in that space, as well as IBM and IBM Research are working on some AIU chipsets that will bring a lot of the rendering within the vehicle itself and improve those capabilities. The second area is we have more than 150 operators, mobile operators around the world running their networks, so their IoT and their 5G networks on Red Hat as an OpenShift platform. So that's a key building block of our connected car strategy. The third area is really around the telemetry data. So we have a platform called Connected Vehicle Insights that is AI powered to be able to unlock insights in the data from the car itself for predictive maintenance and things like that. And then the last area is in the area of over-the-air software updates. So with our Edge platforms and our Edge software fabric, we're able to provision software either at the network edge or at the vehicle edge. And so we bring these solutions together in the telecommunications and the OEM space. So thank you.
Thank you, Bill. So Cameron, I'll come back to you then. Well, you can briefly introduce yourself, even if you already had a presentation. Would you mind to maybe just recap what are the primary services that AT&T offers, but also what is the exciting area that you think it's coming on the mobility?
All right. Hey, so can you hear me okay? Yeah, it's hard to know right here. We provide connectivity. That's about as simple as I can make it as what AT&T does, is provide connectivity to all of our customers, both business and consumer, as well as public sector. And that connectivity comes in the form of 4G and 5G. And as we move into the 5G standalone world, we're moving into an architecture for our networks that is called a service-based architecture. Through something called a network exposure function, we'll be able to provide API access into additional data going forward that was not available before this, that can help to make all the things that these gentlemen on stage have been talking about better. So an example that I love to use of how this can happen is through a capability that we're going to call bandwidth calendaring. You know, all of us in the cellular industry have times that our networks are fully loaded. We call that the busy hour. But we have times that our networks are not that loaded in the middle of the night. Well, we would love to be able to provide the opportunity for usage of that network even when there's not a bunch of traffic on it today. And what better way to do that than to do firmware updates during those times and to calendar that and to provide an easy mechanism for our customers to be able to use that functionality in an automated fashion to update their software-defined vehicles in the future. I'll stop there because I got a whole bunch of other exciting things.
Thank you, Karen. So maybe go to you, Kenta. So from your perspective, from your company, you offer a broad opportunity to anyone in the smart mobility. But what are the most common or the most popular services that you see from your perspective on the smart mobility?
Yeah, smart mobility and Internet of Things, for anything that is connected to the network, one of the most important thing is security. So of course, we can talk about all the fancy applications. Unless the network is secure, you can't rely on that. So one of the important features and what the customers always love about is our capability to provide a secure link between device and cloud infrastructure. So we have partnered with AT&T and the cellular carriers, and also we have built our infrastructure on top of AWS cloud. So what we can do is when the data comes in from the cell tower, it will be routed through carrier network and come directly to our environment that is already on AWS. And then we can provide a secure link to customers' backend running on top of AWS or IBM Cloud or Microsoft. We are providing cloud agnostic secure solutions. So the customers can build a secure isolated network by using cellular 5G network. That is one of the most popular features we have offered.
Okay, no, interesting. So we see APIs, we see opportunities, we see security. Steve, I come to you then. As you mentioned, you've been working in automotive for a long time, but also in Sibros, your primary focus is connectivity. Can you talk a little bit, if you can, about what data is connected, how much data, what do you do with that data, where goes this data?
Yeah, I like this question and I'll try to be very short. I'll try. Vehicles produce an enormous amount of data. Let's start there. And most of it's boring, repetitive, and not much use. So the key is to pull the right data that's meaningful and actionable. And that's what we focus on, either events or conditions that are taking place. The other piece is that throughout the vehicle's life cycle, needs change on what data is going to be meaningful and actionable, whether you're in development with your mule vehicles or your post-assembly line and you want to get a build assessment of that particular vehicle before you ship that vehicle to commerce, or then you're adding data to enhance that engagement with the customer. So the key is to provide dynamic capabilities to pull the data that's meaningful and actionable. And that we just really focus broadly on two parts. Internal benefits. So what is the data that we can give to the OEM or the OEM will consume to make that product better based on how the vehicle's performing, how it's being used, and use that to do enhancements, and provide software updates to enhance that vehicle, or even design around reductive design. The art of design is reductive. What are the things that customers are not doing that maybe you can reduce, and drop the cost of the vehicle. And so it's the internal benefits, and then bringing that vehicle into that customer's digital lifestyle so they understand how that vehicle can be used in a better way. And all of this is enabled, what we focus on, to provide our customers with the ability to log everything out of the vehicle, but only when it's meaningful. So every signal from every electrical bus, for every sensor that's on the vehicle, to even deeper file diagnostic reads from the vehicle. That's what we focus on at Sibros, and that's what we give our customers.
Okay, that's good. Then staying on the data part, maybe I come to you, Chris. So what are the data? What type of data you have in your connectivity? What do you see from AWS point of view?
Yeah, I think sort of before I answer that, I think one thing that's already jumped out at me today is the strength of partnerships, right? Partnership ecosystem to deliver for customers in this space. So, we heard Cameron talking about what AT&T are doing. We work with AT&T on a daily basis. We just heard Steve talking about, the insights that he and his organization is able to provide to their customers. Steve is leveraging Amazon Web Services for some of that, using our SageMaker service. You just heard Kenta say that he's built his platform on AWS, which is great to hear, of course. And then, Bill was talking about Red Hat, where he's talking about OpenShift. And we have a version of OpenShift available on AWS today called Rosa Red Hat OpenShift on AWS. So it's clear that, together we are all partnering to really drive value to customers, which is great to hear. And then going back to the question about data. So for us as a cloud organization, data is everything to us. So making the right decisions based upon the data that comes off the vehicle, that comes off the production line, that comes from manufacturing, that comes from shipping, that comes from all the different industries that actually converge for automotive is key. And we're driven by helping customers to consume that in a meaningful way and pull out what we call actionable insights from that data. So we have a bunch of tools. I think this conversation will certainly go towards AI and generative AI today. We have custom silicon for that. We have custom instance types in our cloud. We have tools that developers can use to consume the data, to consume large language models, to do machine learning. You might have seen just this week there was some press about Amazon investing in a large language model company. So for us, data is everything, right? Everything that we do is based upon the actionable insights that we can pull from the data.
Thank you, Chris. Again, I'm going to stick to the data for a moment. By the way, I will have still a couple of questions, but I wouldn't mind if you also have a question from the audience. So if you start thinking of a question, then I will come back to you and see if you have anything to ask. Bill, you, as IBM, you just released a report, I think, about mobility and also looking at the data. But we talked about, what type of data, how much data, where the data goes. What are the challenges? Can you maybe touch upon what are the challenges nowadays, or what are the challenges of the future that you can see?
Sure. So Barbara's referring to a white paper that I co-authored in partnership with a number of folks, including the GSMA, and it was focused on connected car, and the title was Getting Ahead of the Fast and Furious Flood of Data. So it's all focused on the data, right? When you think about the flood of data, today, if you estimate, there are about 1.5 billion cars on the road. If you looked at it and said, perhaps 20% of them in a period of time in the near future might be somewhat autonomous. Not fully autonomous, but highly autonomous, like maybe level 4. With that amount of data, IBM Institute for Business Value estimates that will create about 300 zettabytes of data. Now, just to put that into perspective, a zettabyte is 1 trillion gigabyte. So it's huge. So what do you do with this data? Some of the data is usable, some of the data is not. Some of the OEMs are on a treasure hunt to try to find out what they can actually extract from the data, right? We think that there's 3 key things that collectively we as an industry and as an ecosystem team to focus on. So the first one is that we think that there needs to be a coverage expansion, because as autonomous vehicles become more prevalent, it's going to be require that there are no gaps. So whether it be for non-terrestrial networks to cover some of the spots, but we do know that we need to improve some of the coverage. That's one thing. The second area is that we believe that the partnerships and collaborative partnerships amongst the community is going to be important, including the operators, the OEMs, the expanded ecosystem, and the city and municipalities from a federal or government standpoint. So that's the second thing. And then the last thing, which is paramount, is we believe that there needs to be trust in the data, and there needs to be security in that data. So IBM is approaching this space kind of holistically, looking at it from those three perspectives. And that's really all focused around the data.
And Barbara, let me just throw a ridiculous statistic in here just to sort of illustrate the scale of this. If you look at all of the data created from the dawn of mankind up to the year 2000, we create more data than that every single day now. So the scale of I don't want to say the problem, but the opportunity is absolutely enormous.
No, we just have to deal with it, right? We have to find a way to deal with it. So maybe one question, you mentioned it, going to certain level of autonomy. I come from Europe, level 4 is not possible, not if I forget it for a while. But here in US you can, so you already have those level 4, I don't think it's level 5, but maybe also level 5. So Cameron, from your perspective, from an operator, what does it changes from, let's say, level 2, 3, 4, 5 on the connectivity aspect?
Yeah, hey, what it changes is that you need a quality of service on that data, because some of it, you can't afford a lot of latency, and you need to make sure it gets to the endpoint quickly. And so that's mission critical data. And that requires another level than just best effort. And one of the things that I think the industry in general has struggled with, take connected cars. It's been all about, with the automakers, how can they get that connectivity at the lowest cost possible? And when we're talking about mission critical data, it can't be at the lowest cost, because that takes up bandwidth that could be used for other purposes that we'd have to take out of the use of our network. And so this is something the industry is going to have to deal with as these level 4 and level 5 vehicles become more prevalent. And I think it might hit us first in the United States.
No, exactly. I think it's already been visible. There was a case in San Francisco, right? So I don't know, maybe Steve, you've been working in automotive for the most.
Yeah.
What is your thought?
I worked with Cruise when I was at General Motors, and I know exactly the problem around quality of service with level 4 and level 5. And I think, there's a lot of good opportunity. I go back to this story when around perception systems, right? And can we use C-V2X technology to help reduce the reliance on these perception systems going forward? And we always joked that there was a porta potty on wheels and we didn't know what it was, right? Is it going to move or not move when these vehicles saw them? But really what I'm more intimately focused on right now is active safety. L4, L5, it's got a long path to get there. But if you think of active safety and you think of these lane keep assist, crash imminent braking type of solutions, is pedestrian detection systems that are deployed on vehicles today, how well are they performing? We're seeing advertisements on TV that it's going to stop for a small child, but does it really? And the automakers don't like to deploy invasive things on vehicles unless they're absolutely certain. And so the effectiveness of these systems are 10 to 30%. It's alarmingly low. And I think that this is where we need to focus on an industry a little bit more, is measuring how well these active safety systems are performing. Because if you can't measure it, you can't manage it, and you can't make improvements on it. And so Sibros, the team at Sibros, I contributed here. We wrote a long white paper that was just recently published in SAE. And we're really excited about what we can do with connectivity to help these roadways be safer for everyone. And so that's really what's motivating me and the team right now, is to focus on more the near term problems and opportunities, and maybe some of this long journey as we go towards level 4 and level 5.
A good point. Yes. So, is there any question? Otherwise, I continue. Anyone? Okay. No, that's good. Right. So, what we can also maybe Kenta, what do you think? For example, talking about assisted systems, so the ADAS in particularly, and what the connectivity can do. There's anything you want to share or anything you're already doing? That's from your company.
Yeah, of course. So the when it comes to those systems ADAS, we can't rely on the network side to make a decision when it comes to there's something the child is in front of the car and the car has to stop. That decision must be done locally on the edge or smart mobility or automotive device. So the one thing that connectivity, or two things that connectivity take an important role here is to collect data from the systems and what happened in the time that the system actually kicks in and stop the vehicle, and also what was the happening around the car, not only the video image or the picture, but also all the sensor data coming in from the car. Those have to be uploaded to cloud side and processed so that we can learn from it and make sure the system is working properly. And also, if it's not working properly or should have done something different, that has to be detected and applied to the new version or new later software. And once that is determined, this is the second part. Connectivity takes an important role. That is to apply the change and updated algorithm or updated machine learning model to the local, all the vehicle fleets in the world, so that there has to be a updated firmware distributed to all the vehicles after the improvement has been done. And of course, this communication has to be done securely between the cloud and all the cars. So those are the important things that the connectivity takes in this scenario.
Okay, so just stay maybe on the machine learning and the AI aspect, and I come to you, Bill, obviously. What do you think it's possible to do in the automotive with AI, or what you already do? So.
Sure. So just a few examples. Again, taking a holistic view, if you look at generative AI or AI in general, so the ADAS systems is an example. Generative AI will be able to be used to help with the training of some of these systems. So you'll be able to create foundation models that can be fine-tuned instead of having to retrain completely from scratch. So there's some advancements going on in that space. If you look at from a network operator standpoint, generative AI is being used to help operators deploy spectrum better. So for RAN optimization, to be able to make sure that the coverage is good. Generative AI or AI in general is being used for anomaly detection, to assure that the service levels of the network are up and running and are automatic from a no-touch standpoint, correcting the errors and the problems that these vehicles are going to rely on. And then I think, a practical method when you look at if I kind of change to a little bit on the over-the-air software updates, there's some real today problems that can be solved, right? We're talking a lot about what's happening and what's coming down the road, and I know we've got to keep an eye on that. But there's some real logical problems today. Tesla has really kind of raised the bar considerably. So I spent a lot of time with a number of OEMs, and they're looking at what do they need to do, right? How can they adapt their business model? How can they treat the car more as a software asset and to be able to get over-the-air software updates? So we're working with a tower company in partnership with a large mobile operator in the US and an OEM to be able to provide software assets and resources closer to the vehicle, closer to pinch points, like perhaps at the factory or at some of the shipping or the train ports, to be able to do bulk uploads of new software releases instead of bringing them back to the automotive repair shop and having to pay for warranty repairs. So I think the balance of what's coming down the road in the future and what can we do today to help solve some of these real problems is a key focus area for IBM.
Okay, that's interesting. Maybe change it a little bit. In your presentation, Cameron, you also talked about, you explained the journey or the CV2N or CV2X. And you also mentioned about the changes in electrification. And what does it mean on the connectivity aspect for that, the infrastructures? So what do we need from the connectivity, in your perspective,
Yeah.
compared to a vehicle, let's say?
Well, with an electric vehicle, there's obviously there's no engine, but there is a large battery that has got to be maintained, understood how it's operating. I think Steve got into the fact that some of this data is very valuable to the automakers. It's also valuable for the battery manufacturers. So there's multiple contingents that would have interest in the data that is coming off of an EV. So that's number one. Number two is just the linkage between the electric vehicle and the charging station. Look, there have been studies done, there have been publications out there that if you are going to take a trip across the country with an electric vehicle, it's going to be an adventure. And we're in like the wild, wild west again, to use a US terminology, where the whole infrastructure has not been built out yet. So that needs to occur. And as that gets built out, all of those EV chargers need to have connectivity, because the last thing that you want, again, is to plan your trip to be at an EV charger and you get there and it's out of service, or you don't have anywhere to charge for a length of time that you hadn't planned for. There has to be connectivity that comes along with the EV charging stations, and all of this can help with all the algorithms to make sure that you are planning your route correctly.
So yes, Steve, yeah.
I agree, Cameron. I mean, the shift towards EV technology is fascinating, but there's challenges. And I agree with everything that you said. I mean, our customers are mining the data from the BMS systems to look at how to optimize the usefulness of the battery. There's a lot of things that they're doing with that data to improve the technology on the vehicle. We just hosted a webinar, which I also found fascinating. I don't know how many people in this room own an EV. I'm sure there's a few. And then how many people actually bought a used EV vehicle? And so that the number of hands go way down when you do that. And so assessing the battery health for second and third owners and fleet operators is also a key part of what you can do with connected vehicle data, because it's not just a one-time I measure this battery and I can get an accurate understanding of the health of the vehicle, not the charge, but the health of the vehicle and how many useful years or miles it has left on it. But creating more of a industry standard around measuring vehicle health, and also what goes into that, which is how you've used that battery over the life of the vehicle. And so using this connected vehicle technology to kind of look at hard accelerations, how the battery was charged, is fascinating. And we're trying to bring that to light for our customers and as well as the industry, is that can we use this connected vehicle technology for that?
Kenta, Chris, I know that this is a nice topic. I was just fascinated because I talked to one supplier of battery to OEM, and when they told me the amount of data that they transmit, they collect for the battery, I was shocked. So do you want to say something about it, Chris or Kenta?
Yeah. Yes. So I can't agree more. All the EV charging stations and all the infrastructure needed for EV have to be connected. We have multiple customers of ours who have done EV charging stations connected through cellular network, and definitely I also drive EV, and if the EV charging station is congested, it's a big problem. And also, what is important is not only just knowing the status of the station, we also need to predict when the stations will be busy. For that, we have to take the input from all the weather forecasts, traffic information, all different kinds of data, and process it to provide a prediction. So for that, it's important to collect not only from data from the vehicles and connected EV charging stations, but also from all the maybe even some farming sensors and raining sensors and maybe some people's traffic cameras information. All these things need to feed the data to cloud, and we need to apply AI and Gen AI to predict all these, what's going on to happen in each EV station. So this is an exciting time. We have all the pieces to achieve this, what I just talked about, and also Cameron mentioned in his presentation. So we are in an exciting time to achieve everything. And the key thing is actually the connectivity.
Chris, yes.
And it kind of comes back to this topic of trusted data. So you can have the data, that's great, but what do you do with that data, right? So, if the data tells you that an EV charging station is available, then it must be available. It can't be wrong, right? What happens if you pull up there and it's not available and they told you it was? But I think more importantly than that, if a child steps out in front of a car, what does the car do with the information? It must do it correctly. If you can save one child's life with all of this, then it's worth it, right? And that's where we work. So, we're changing as an organization. I think the industry is telling us that data is real time today. You can't afford to ship it all the way back to a cloud somewhere and then have it all come all the way back. What if you're in somewhere that's remote and that's hundreds of milliseconds? That can mean the difference between a child living or dying in that situation. We created our cloud 17 years ago. 4 years ago, we created an edge organization. That edge organization is telling the market that they see a future where more workloads exist at the edge than they do in the core of our cloud, because data is real-time. Real-time decision-making needs infrastructure that is close to where that decision is made. And where is the edge? I think that's a big debate today. Is the edge your mobile device? Is the edge the car? Is the edge something that's on your body? Is it sensors? So that's always changing, but definitely what we're seeing is this proliferation of data that needs to be processed in real time, close to where the data is being generated.
No, understood. Yeah. So sticking maybe on the safety aspects. So we mentioned before, and also you, Steve, mentioned ADAS system or what we can do now. But what do we think we can do more? Well, we cannot do now, or we are not doing now. So ADAS is one of the, I think it's nowadays most of the car, and this is globally, they have this assisted, driving with warnings, if it's a car coming from the left or right, the blinking, the noise. But are we doing enough, or can we do more? Cameron, yeah,
I'll start. I think that as we move into the era of 5G, and I agree with you, we need coverage everywhere. But one of the things that 5G will enable us to do as an industry is some of this has to be done locally, but vehicles are going to have many more video cameras in the future. And those video cameras are going to be necessary to process images locally, so there will be some edge at the vehicle. Some of that, though, needs to go back and be processed further back into the networks and used for other purposes. And so that is an area that I think is ripe for us all to work on how we accomplish together.
Anyone else want to add on? What can we do?
Yeah. Well, I think if you think about what Cameron said, some of the data is going to be processed in the vehicle, and some is going to require low latency connections back. I want to talk about the connection part for a moment, because what I think a lot of people don't realize, first of all, is I think mobile operators are going to continue to play a very key role in this ecosystem and be able to monetize a significant part of this value chain. But one of the fundamental challenges that the industry is facing, and this is through interactions and business with the OEMs direct, is there's no such thing anymore really of global mobile roaming. So anything of value that's manufactured in one country that needs to be shipped to another country, like a car or a heavy equipment, as an example, you need to have a mobile connection in the country that unit resides in. So we think of it, we take for granted as travelers that, hey, my mobile device connects everywhere. I'm an AT&T customer and I can go around the globe and get connectivity. But that's not permanent roaming. So if I'm a car and I'm in Korea, as an example, by law, by regulatory compliance, I have to, for data sovereignty requirements, I have to make sure that I'm connected with a local carrier and that there are certain regulations around where my data can be sent and what I can do. And that gets complicated and magnified by many, many countries in South America as well as the Middle East. So I think there's an opportunity for global mobile operators, but I also think that there is really going to be some partnership requirements. And the burden can't just fall on the OEMs because they're challenged with having to figure out, how do I maintain consistency across 20 different vendors around the world, the same level of SLAs, the same way the data is presented. So these are some challenges, again, that are facing us right now here today that we need to address as we start to look at ADAS and other things like that.
And I think, sorry, Steve, I think automation is key. There's a lot of data, there's a lot of telemetry coming out of devices. What do you do with all of that? And I think the mobile network operators, you heard Cameron talking about network slicing earlier on, for example. If there is a situation which involves safety, then the data needs to be prioritized over someone's Netflix, for example. So, and how do you do that at scale? So it's all about automation in the networks.
Steve?
Yeah, I'm going to maybe answer it the way I want to answer this, but what we're doing more of is enabling really any mobility device to have embedded connectivity. I think that's foundational, and that's very important. So we're on a large number of two-wheelers. I mean, the two-wheeler market is like 60 million new bikes produced every year compared to 90 million. So it's much bigger than I even realized. And we're enabling those customers like KTM to have embedded connectivity and have it deliver value, where they realize the value that comes from it. And I think that becomes a building strategy where, then I get passionate around how do we make these bikes safer? How do we make our roadways safer for everyone? And then I turn to Cameron and I say, let's get CV to X widely adopted. Let's make sure that these different types of mobility devices are communicating with each other, and let's make the roadway safer for everyone. But it starts with them seeing value on why they have embedded connectivity in the first place, for software updates, for data logging, for improving that, bringing that vehicle into their customer's digital lifestyle. And then we can build on those advanced services and really make our roadways safer for everyone.
Good point. Actually, you mentioned the two wheels. Yeah, we always talk about cars, but there are other vehicles on on the roads. Are we addressing this one enough or not, from your opinion? Do you actually, Kenta, do you have customers on two wheels?
Yes, we have customers who have the connected e-scooters. Basically the same thing applies for those smart mobility devices with two wheels or a much smaller number of wheels. They need to be charged, and they need to also collect data. And the route that those scooters can take is different from the four wheels automotives. So there has to be a different type of navigation, and that has to be also require the machine learning and cloud side processing as well.
Oh, good. And do you see the difference, Cameron?
Oh, for sure. There's a utility vehicle right there that is connected. That's just an example of one additional thing besides a car or a truck that is better connected than not connected. Yeah.
So they're coming up. So they're coming out. They're coming. So
they're coming. But I think there's always economics at play. A motorcycle. They need to figure out how they're going to put a telematics control unit in it.
Space is limited.
Space is limited, and how they're going to use the data. And so all of this, I think they're thinking through.
Steve,
I was just going to add, one of the benefits, what we saw, one of our very first two-wheeler customers that was doing an electric bike, they realized they oversized the battery pretty quickly based on how the customers were using the vehicle. And they were reducing it, I can't remember the specifics, like 20 kilowatts down to 12 kilowatts. It's a $250 million year-over-year savings that they could achieve by just the art of design is reductive. Just understanding how these, because you don't really know. You do market research and you try to build the perfect vehicle for what you think you need, but you don't know until your customers actually start using it, and you can measure how they're using that particular mode of transportation, and you can optimize it. And that's what they're looking at right now.
what you said, Steve, that actually you reminded me one important difference in terms of the smaller scale smart mobility devices. They have much less battery compared to full scale automotives. So you have to really save battery and make sure the device communication is done with the minimum overhead as possible. So the LTE Cat M and low power LTE and 5G is going to be really important for those devices. And also, when it comes to connecting to cloud and sending data, the devices have to do authentication and encrypt communication, and all those also consume battery in each device. So the connectivity provider also has to have a feature to make sure secure communication is achieved by still, and also still need to offload those authentication and encryption to the connectivity provider side. That's something we have been offering as well. So one of the customers who has the smart mobility scooter and also the wheelchair, they use our protocol conversion feature so that they can just send a single IP packet over LTE, and we can call a cloud API, AWS or IBM or cloud service API on behalf of the device that can actually reduce the communication overhead and battery consumption. And this technology is important for those battery powered devices in general.
Yeah, I think we shouldn't forget about two-wheeled vehicles. That is fundamentally the same. So the rider of a vehicle needs to be kept safe. That's priority number one. Sure, there might be a little less in-vehicle entertainment on a motorcycle. I don't think that sounds very safe, but
Hopefully.
Fundamentally the same principles apply.
Okay, no, it's good because we forget sometimes that are not just cars and also trucks and not, there's a lot of different vehicles and they can be served the same. So looking at the time, then maybe I wanna close and get an opinion from all of you. What is in your view the things that is more, let's say, interesting at the moment to work on that we need to work on, let's say, in the coming year? I know it's a bit over, either is urgent because we need to fix it or because it's interesting, or you mentioned a software-defined vehicle. We are not there yet, I guess. They are happening, but are we there yet? Or what is going to happen?
Yeah, I would say if you look at the industry, they probably don't understand beyond the companies that are here what the future holds from a connectivity standpoint. What is the art of the possible with 5G? We need to do a better job of explaining that to them so that they, number one, understand it, because they're not cellular experts. And number two, so that they find the value in what we're offering and they can use it both internally and externally for customers.
I think for us, we really recognize what happens when you abstract software away from the underlying hardware. That's what really got the cloud, economy off the ground. That's where we see the fastest innovation once you're able to do everything at the software layer without worrying about what happens to the underlying hardware. That's where we really see innovation speed up. And I think that's exactly what we're going to get with software-defined vehicles. So we're excited to see that.
Neil?
And I think, for an ending for me is additionally in the report that we produced in partnership with the GSMA, we focused on consumers' willingness to pay for services. And there were a number of services that actually consumers are willing to pay for. So anti-theft and security as an example. Predictive maintenance and performance monitoring was another service that are willing to pay. And clearly around some of the entertainment services. So I think all of this needs to be balanced around what are the consumers' willingness to pay for some of the services that we want to deliver within these connected vehicles.
Kenta, Steve?
Yeah, I mean, in addition to the software and features, all these features, in addition to entertainment system, all the features on the connected vehicles can also be subscription basis. For example, autonomous driving that can be licensed under monthly fee, and to achieve that, the connectivity is important. You have to make sure the subscription fee is paid by the actual users. That's another important thing happening in software-defined vehicles, and connectivity takes the important role there as well.
Steve?
Yeah,
close
I'll
it up.
just say sometimes I don't like the word software-defined vehicle because it does conjure up this idea that you have to get to zonal architectures, domain architectures, high-performance compute platforms to take advantage of what embedded connectivity can bring to our customers with traditional, ECUs in the vehicle. You can still remotely update that vehicle. You can still add new features. You can still make improvements. In fact, you have to have pretty deep pockets today to actually get to what I will call a software-defined vehicle. So adding embedded connectivity, the value is there, and we're seeing it across the space and being able to, improve that product. I mean, you think of the automotive industry, 140 years to build an internal combustion engine and to get it to the point where it is today. We need to use this connection to build a better product to give to our customers. And that's what we're on. We're on an accelerated path to build better EVs, and every electrical architecture that's out there today can take advantage of that, because a lot of these companies are startups. They don't have those deep pockets. They're stitching together things, and they're actually just focused on the BMS and the VCU and differentiating on that, and that's fine. We can update those as well as the rest of the vehicle. And so that's my closing remark. It's a little scattered, but I want to get it all out there as
It's
quickly
good.
as I could.
So yeah, so next year I hope to see, first of all, that there is a better communication, so we know more what to do with the connectivity, and that we see more improvement, maybe on the safety, also on the services, also on delivering customer services like the charging station. Or we'll see. Thank you very much. So I want to please, if you can, give an applause to my speakers on this panel.